All right, they've already put, we have a rational function, and it's already in factored form, which is really nice. So we have m of x equals, and this gives us a great opportunity just to review a few things here about our rational functions. Okay, I can see we have a factor on top that is the same as a factor on the bottom. A lot of the students use a word, they just cancel out. Really remember they reduce down to 1. So now I have 1 over 3x minus 4. If I take x plus 1 and I set it equals 0, I end up with x equals negative 1. So there is a hole at x equals negative 1. The graph has no holes, wrong. The graph has a hole, oh, it doesn't have 2 holes, it only has 1 hole. The graph has a hole, no, that's wrong. The graph has a hole at negative 1 because they both have a common factor. All of that is true. And then we also can see that sometimes what will happen, just real quick, sometimes what will happen, let me just give you a different example. Let me just give you a different example here. If I had something like this, okay, this is completely different. I just want to let you know why I was hesitating to select G, is I do want to point out that in this particular one, we can see we have a factor on the top and the bottom. It's only a 1 for 1. So right now, students may say, we have a hole at x equals negative 2. Whoops, sorry. We have a hole at x equals negative 2. That's a potential hole, and that is true. It's a potential hole. But then you always have to check the vertical asymptote. So here I can see I have a vertical asymptote when I set it equal to 0 and x equals negative 2, and at x equals positive 3. Your vertical asymptotes will always trump a hole. So see how we have both of these? When that happens, and it doesn't happen very often, there is no hole there. It's actually a vertical asymptote. Now this is different than what you see in question 23, but I did want to review that with you. So D is the correct answer for 23, but this random example I gave you would have no holes, but it would have vertical asymptote at x equals negative 2 and x equals positive 3.